Round 1 and round 2 were like fun, and then the other rounds were like didn't.
All right, well, we will figure it out.
We should like do like one from each one, or all of them. Honestly.
There you are. Okay, so we're going over these rounds here. Let's just go one by one, and I'll be sure to at least do one problem from each, so we have a nice review. And we'll go from there. They're posted on Jupiter already, silly goose. You turned it in.
Oh,
Stop. That was kind of sad.
Can you guys still see? Okay. All right, so here were the answers for the beginning. Remember, all you had to do with these, write each in standard form. So the first one, you just have to multiply it together, put them in order, make sure here if it's subtraction, you got to subtract each of these. So you should have ended up here. Any problem with the standard form part?
Wait, can you do number 4 out?
Sure. Grab myself another sheet. So number 4, I've got some parentheses inside parentheses. So the first thing I'm going to have to do is distribute that 4 in there. So I'll have 3x squared x, and now let's distribute that 4. So that'll be plus 4x plus 12. I'm going to flip that around because I can't stand having the x second, so I'm going to write it as negative x plus 2. You don't have to do that, but personal preference. And then let me zoom in this a little bit. Now in my first parenthesis, I have some like terms I can combine, so let me do that. So it's now going to be 5x plus 12, and then I'll have my negative x plus 2. So now this is all multiplication, so it's up to you how you want to tackle this. You can do the 3x squared times this and then FOIL those two answers together. You could FOIL these two together first and then multiply by the 3x squared. I think that's what I'll do, but it really doesn't matter because it's all multiplication. So 3x squared, and then I'm going to FOIL these two. So first, negative 5x squared, outside plus 10x, inside minus 12x, and then last plus 24. All right, let's combine like terms. And now all I have to do is distribute through that 3x squared. Oh, what's that? 72? Is it? All right, so there is my answer in standard form. And then I notice it's degree 4, so that's called quartic. And then I've got 1, 2, 3 terms. So this thing would be a trinomial, quartic trinomial. All right, so any other questions round 1? Okay, so let's flip on over to round 2. Round 2. Okay, we're doing long division here. I definitely want to do number 4 together.
Yes, please.
Does anybody want either 1, 2, or 3? Are you sure? I'm going to do one anyway. So does anybody have a preference over 1, 2, or 3?
No.
I'm going to do 3 only because that one has, so I'll do 3 and 4. Okay, so on 3, if you're going to do this with long division, remember that no matter what, I need 0 placeholders if any degrees are missing. So on the outside, I'm going to have my x minus 2. But then on the inside, I have x to the 4th minus 3. Oh, wait, no. I don't have it to the 3rd term, right? So I actually need a plus 0 x to the 3rd. minus 3x squared, and then I don't have an x to the first term, so I'm gonna have a plus 0x minus 10. So when I go to do number 3, that's how it should be set up. That's a 0. And then double check 4, 3, 2, 1, none. Okay, everybody's there now. And now I'm ready to begin. So we ask ourselves, what do I multiply x by to get x to the 4th? And the answer is, we multiply x by to get x to the 4th. X to the 3rd. So I put an x to the 3rd up top in the x to the 3rd column, right? Everything in this vertical column here will be x to the 3rds. Multiply it through. I get x to the 4th minus 2x cubed. But then you have to subtract that whole line, right? So you're a minus and you were a minus, so you become a plus. First terms canceled just like they're supposed to. Okay, I have a 0 and a positive 2, so that's a positive 2x to the 3rd, bringing down my next term. And then I do it again. What do you multiply x by to get 2x cubed? Everybody? 2x squared. So up top, I put a positive 2x squared. Multiply it through. 2x cubed minus 4x squared. But then I subtract that whole line. So you're now a minus and you're a minus, so you become a plus because minus a negative is a plus, right? These two, that leaves me with a positive 1x squared. Bring down my next term, plus 0x. What do you multiply x squared by, x by to get x squared? X. So I put a positive x up top, multiply through. Subtract the whole line. Cancels, I get 2x, and then one more, bring down that minus 10. And what goes up top? Plus 2. Multiply it, I get 2x minus 4, subtract the whole line. Bada bing, bada boom. I get a negative 6 as a remainder. So that means I'm just going to write my remainder as minus 6 over whatever you were dividing by, x minus 2. And that whole thing, all of that is my answer. Yes.
Is this recorded?
It is.
Okay.
I hope, yeah, it is. Okay. Number 4 is trickier because what you're dividing by isn't a binomial. You actually have a quadratic that you're dividing by. So if we take a look, so here just for the internet, here's number 4. There's number 4 right there. All right, but I'm going to operate the same way. I still need 0 placeholders. So if I look here, I have 4, 3. Oh, no, I don't have 3. So I'm going to need a 0 placeholder for 3. 4, 3, 2, 1, none. Okay, that's good. This one's missing a degree too. This one has x squared, but I don't have an x in the first term. So I'm going to put a 0 placeholder in for both. So let's do this one. So on the outside, I'm actually going to have x squared plus 0x minus 2. And then on the inside, I'm going to have 2x to the 4th plus 0x to the 3rd plus 3x squared minus x plus 6. 4, 3, 2, 1, none. Okay, now we're ready to go. And I operate the same way. What do you multiply x squared by to get 2x to the 4th? 2x squared. So I put it in the x squared column. Multiply it through. I'm going to have 2x to the 4th plus 0x to the 3rd minus 4x squared. Subtract the whole line. Minus, minus. You're already a minus, so you become a plus. That one cancels. I have 0x to the 3rd plus 7x squared. Bring down my next term, minus x. Repeat. What do you multiply x squared by to get 0x to the 3rd? 0x. So up top, I put a 0x, multiply it through. Subtract the whole line, minus, I mean, these don't really matter because they're zeros, but whatever. Those cancel, I get a 7x squared. And so I have negative 1x there, right? So negative x. Bring down my plus 6. And what goes up top? 7 plus 7. Multiply it through. Let's see what we get. 7x squared plus 0x minus 14. Subtract the whole line. Minus, minus. You're already a minus. You turn to a plus. You're gone. You're a negative x. You're a plus 20. Oops. Now, there's nothing left for me to bring down, right? There's no more. So this is my remainder. So I'm just going to put it up top, divided by whatever I was originally dividing by. I don't need the 0x here. In fact, if I was going to write my answer all nice and neat, I would skip it here too, right? Because I don't need, it's just a 0. Of course you can. I have faith.
Are you sure?
Yes.
Oh, no.
Just because you didn't this time doesn't mean that you can't.
There we go.
All right, so there is my final answer for this one. Again, I just would write that 0 because we don't need it. Is that better? Okay. Round 3. So we're doing synthetic. On number 1, I hope you saw that I said do long division on this one. Did you? Oh, sorry. Because remember, you can't do it if the lead coefficient isn't a 1. I mean, there is a way, but it's so much more complicated. You might as well just do the long division. So I would, sorry if you tried to synthetic that one, but yeah, that should have been a long division one. The other ones though, I can do. So how about 2, 3, or 4? Anybody have a preference on 2, 3, or 4? Three, you got it. All right, so number 3 here. Okay, so let's drop down our coefficients. Let's first make sure we don't need any zeros. 3, 2, 1, none. Okay, so our coefficients are 3, -2, 2, and 1. And then it wants me to divide by x plus 1/3. So what is the number that I'm actually plugging in? -1/3. Whenever they give you the binomial, you really want to take the 0 that comes out of that. That's what you're plugging in when you have something like this. So here I'm going to plug in a -1/3 and we're going to see what happens. So I've got my coefficients, -1/3 over here. First number just gets dropped down, 3. -1/3 times 3 is -1. -2 and -1 is -3. -1/3 times -3 is now a +1. 2 plus 1 is 3. Multiply through, I get a -1, and I get a remainder of 0. So what does that mean? That means that this is my answer. Remember how this works. That's my remainder. That's my constant. This is x to the first x squared. So when I write this answer all nice and neat, I'm going to write it as 3x squared minus 3x plus 3. I don't have a remainder, so I don't have to worry about that part. Yep. Yeah, you would, if say my remainder was like, I don't know, 7, you'd write plus 7 over the x plus 1/3, like that. Yep. Okay, any other problems 1 through 4? Now, 5 and 6 are the exact same thing, or maybe you don't remember that they are, but they are. But you're literally, so if I'm going to do number 5, they're saying, well, hey, what's the value of this function at -2? Sure, you could take -2 and plug it in directly and do all that work, but we found out that there's a way faster way. You can just do synthetic division, plug in -2. So whatever they're asking you to plug in, you plug that in directly. And whatever your remainder is the answer. So I hope you didn't do 3 times -2 cubed minus -2 squared.
Please pardon the interruption. Would all culinary arts students go on the field trip to Holyoke Community College? Keep downtown culinary arts right now. Thank you.
Could you do it that way? Sure, but look how fast I can do it. I just dropped my coefficients. 3, 2, 1, none. I pop in a -2. And then I just bing, bang, boom here. Ta-da! -8. There's my answer. So much faster. So if you need to evaluate a polynomial at any given number, you just do the synthetic, and then whatever the remainder is your answer.
You don't have to take the opposite. though,
No,
right?
you only take the opposite when you're given the binomial. So if they just give you a number, you just pop in that number. Did you get 0 for 6? That one's just a lot of fraction action. Do you want me to do it or no? Yeah, okay. Let me get a new sheet. So if I'm gonna do number 6 here, let's drop down our coefficients. 1, 5/3, -2/3, 6, and -2. We are plugging in 1/3, and we're gonna hope that things just kind of work out nicely. 1/3, drop it down. 1/3. Okay, what's 5/3 and 1/3? Yeah, it's 6/3, which is just 2. 1/3 times 2 is just going to be 2/3. -2/3 and +2/3 is now 0. 0, 6. 1/3 of 6 is 2. Ta-da! So even though it looked like it was going to be really bad, it was fine. So the answer is just 0. Right? Because whatever the remainder is the answer, the value of that function at that number. Okay, so there is round 3. Are we all okay on round 3 now? Okay, round 4. Here it is.
3.
I can, but you're supposed to skip it.
Oh, we were?
Yeah.
What? I said that? I didn't look at the sheet.
Oh, well,
Wait, why were we supposed to skip it?
I'll do it now, just so you can see it. So there is a way to factor things that look crazy like this by sort of doing a little bit of a substitution. See how I have this x plus 6, and then I have x plus 6 again. What if I just for a second, okay, just for a second, let's just say I use w, and I pretended that w represented x plus 6. Okay, just pretend. And then I'm going to rewrite the original, and it's going to look like this: 2w squared minus 5w plus 2. That thing is way easier to factor. Do you see that? Right? All I did was swap out an x plus 6 for w just for a second. And now I can factor this thing easy peasy. I do slide and divide. You got to do whatever you do. So factors of +4, that had to be -5, would be a -1 and a -4. So there's that thing factored. But remember, wait, w isn't really just w. It's really x plus 6. Oh, so let's put the x plus 6 back. So instead of writing w, I can write x plus 6 minus 1, x plus 6 minus 4. And that simplifies to just be x plus 5 and x plus 2. Oh, but why are my answers so different than that? So just -5 and -2? That's not what the answer says. Did I mess up? I don't think so. Is there one like this on your test tomorrow? No. So I'm not really overly concerned about it, but I want to know why it's not right. So give me a second. Let me just see if my key is wrong or if I just messed up right now. Let's do. Four, negative, where? Oh, thank you. See, and that's one of the big problems with slide and divide, is that you just slide and then you never come back and divide. Oh my gosh. So that's 2w minus 1. Thank you. Oh my goodness gracious. I'm like, I swear. Okay, now let's replace the w with the x plus 6. So that'd be x plus 6 minus 1. X plus 6 minus 2. And then I can just simplify from here. So that's a 2x plus 12 minus 1 would be a plus 11. Yeah, okay. And then it matches the holy Toledo. So that's how I get my zeros of a negative 11 halves and a negative 4. Yeah, be careful. If you slide and divide, you better watch yourself. What other ones from this one, if any? Let me see if there's any that are jumping out at me. So number 1, I really hope that you factor this one by grouping, right? If you literally draw anytime you have 4, if you have 4 terms, always check if there's something to pull out of the whole thing. That's always step 1, no matter what you're doing. There's nothing to pull out of the whole thing. Once I see I have 4 terms, I'm going to try and draw the line and factor each side. And number 1, I believe that works on, so that's fine. If you have something like number 6, this one is not 4 terms, right? We've got 5 terms, so I can't just do that. So there's nothing to pull out of the whole thing. So what do? This is where you just have to come up with your list of numbers that are going to work and plug them in until someone does work. Clearly, positive 1 and negative 1 work. So you find an answer that works pretty quickly. But you don't have to keep going after that. So let me just show you. If I drop down my coefficients, 4, 3, 2, 1, none. All right, so when I plug in a positive 1, let's just see. So let's pretend I don't know that 1 is going to work. I'm just testing this out. So let's see. I drop down a 2, negative 13, negative 13, 10, 10, 25, 25, 0. Okay, ding, ding, ding. Great. Now, remember what's left. There's your constant, x to the first, x squared, x to the third. So now I have this. Now this is 4 terms. So you can try to factor by grouping now, right? Split it in half and factor both sides. Unfortunately, I don't think that this one works. But if it did, oh my gosh, then I wouldn't have to keep going with the synthetic. Too bad, so sad, it doesn't happen on this one. So you got to keep going with your synthetic until I can get this thing down to a quadratic, which I'm really close to it. So let me just drop down those coefficients. Don't forget, if I were you, so if I had just plugged in 1 and I was like, oh, sweet, 1 just worked, I would plug in 1 again, because you never know if 1's going to end up being a double root. And it's such an easy number to do. I already know it's not going to work, but let me try negative 1, see what happens. Hey, look at that. And now that I'm down to this, so there's x to the first, x squared, 2x squared minus 15x plus 25. This is a quadratic now. You can solve that by, if it factors, great, then factor it. If it doesn't, then you can do quad formula. You can complete the square. Does that make sense? Does anybody have questions on round 4? All right, then, round 5. What do you have for us? It's the same thing that we were just talking about. So none of these, I'm still going to try and factor by grouping. So it looks like 3 probably works, factoring by grouping, right? Yeah, 3 should work. But I think that's it. So
I didn't get this. I didn't get that far.
oh. Does anybody have a particular one on this page that they want me to do? Adam? Sure. We get a new sheet. All right, number 2. Let's see, I've got, this one's not going to work by factoring by grouping.
Wait, could you do the first two? Because I think,
Oh, it says 2 twice.
yeah.
Yeah, sorry. Okay, so x cubed minus 5x squared plus 2x plus 8. All right, I'm trying to find the roots of this thing. I'm looking at this. You could try and factor by grouping, but I can already tell it's not going to work. All right, so my only other choice, I got to come up with that really cool list of possible rational roots. Do you remember how to do it? You always take the factors of your constant, which in this case is 8. So the factors of 8 are 1, 2, 4, and 8. Then you take your factors of your lead coefficient. In this case, the lead coefficient is just 1. So we're really lucky because the only factors of 1 are 1. So that really cool list of possible rational roots is going to be positive and negative. Don't forget positive and negative. All of these numbers divided by just 1 in this case. So I get 1, 2, 4, and 8. So that means if there are any rational roots, they're gonna be one of these numbers. So now what do? I'm gonna drop down those coefficients. 1, -5, 2, 8. And I just have to sort of work my way through. So I'll start with a positive 1 and see if it works. 1, -4, -4. I already know that it doesn't work. So I'm gonna stop. I'm gonna try -1. Of course, I'm not even using a pencil. So this is gonna get messy. So that'd be -1, -6, 6, 8, -8. Ooh, yay. So now I know that -1 is one of my answers. So if I'm just keeping like a tally somewhere, -1 is one of my answers. The others, how many are there going to be altogether, by the way? There should be 3, right? It's whatever the degree of the whole thing is. I just found one of them. Well, now look where I'm at. I have, there's my constant, x to the first, x squared. So it's a quadratic, x squared minus 6x plus 8. All I have to do is solve that quadratic and I'll be done. Are there factors of positive 8 that add to be -6? -2, -4, right? So the other 2 answers that I'm going to get are a +2 and a +4. And there's my 3. I'm done. Does that make sense? Okay, anything else around 5? Or we're feeling okay? Ish. They all work the same way. So, but besides 3, do it by grouping, right? Because you can. You guys know what I'm talking about, right? Let me do it real quick. I get nervous that you are just like, yeah, I know what you mean, and you have no idea. So here's number 3. So whenever you have 4 terms, you should be trying to literally draw the line, factor each side. That'd be x minus 5. Over here, I can take out a -1, I get x minus 5. Once I realize, hey, my parentheses match, that's how you know if it works or not. If you can get these 2 parentheses to match, then yes, you can factor by grouping. Take out that x minus 5. The other factor is what's in front, x squared minus 1. And then I hope you realize, oh, that's just the difference of 2 perfect squares. So that just splits into x plus 1, x minus 1. And then 3 answers I was supposed to find, I got them. +5, -1, +1. Yes. So see how fast it can be with factoring by grouping? So fast. It's just that not every single one can be done that way. The ones that can, do it. Save you so much time. All right, so there's that. Let's take a look-see-loo at round 6. You were supposed to skip number 4. So I hope you didn't touch 4. This, they're just giving you a head start. They're saying, hey, 5 works. So if you do 5 synthetic into this, you already know you should be getting a remainder of 0. And then I can just work from there. So, but it's literally the exact same thing as round 5, just giving you a head start. Let's do 3 together though. 3 is a little weird because the root that they gave me is this 1 plus I. So I know I'm looking for 4 roots altogether. They actually gave you 2 roots here, whether you knew it or not. If 1 plus I is a root, who else is a root? 1 minus I, all imaginary and all irrational, always bring their conjugate pair to the party. So you actually know 2 of your 4 roots. So now it's kind of up to you. Do you want to use these 2 zeros? Do that sum and difference of products thing that we have and then do the long division in? Or I have a feeling most of you are just going to bypass that anyway and just take the factors of 4 divided by the factors of 1 and just plug them in until somebody works. Since 4 doesn't have that many factors, it's 1, 2, and 4. And my lead coefficient is 1. There's not that many numbers to plug in. When I have 15 numbers to plug in, I don't want to do that. So I might use these zeros, but in the case like this, I wouldn't even look at this really. I would just say, oh, okay, cool. If 1 plus I is a root, then so is 1 minus I. Now let me just plug in the factors of 4 until someone works. And clearly it works pretty quickly because I get -1 works and then also -2. But once you find one of them, you can find the other. Oh, maybe not, because you get, it depends. Maybe it would be factor, maybe you could group it, I don't know. Anyway, do you want me to do 3? Does anybody want me to do 3? Raise your hand if you want me to do 3. Okay. So, my possible irrational roots are going to be positive and negative. Factors of 4 divided by 1, right? Because my lead coefficient is just 1. So in this case, the possible rational roots are all really nice and easy. It's just going to be 1, 2, and 4. So again, I'm kind of ignoring the root that they gave me for a minute. I'm just going to be like, pretend I don't even know that. Okay, so let's drop down our coefficients. 1, 1, -2, 2, and 4. 4, 3, 2, 1, none. Okay. So I would plug in 1, do it out. I'm looking to get a remainder of 0, right? I already know it doesn't work, so I'm going to cheat a little bit and let's just say, oh, I tried 1, it didn't work. Oh, okay, let me try -1. Let's see what happens. Drop down the 1. -1 times 1 is -1. 0, 0, -2, 2, 4, -4. How about that? I get a remainder of 0. That means -1 is one of my answers. Right? Don't forget, I already had 2 more of them. I already have 1 plus I and 1 minus I. So there's only 1 more left to find. But what is it? Well, so now I'm here. Let's see if I could, I don't think I could do any kind of cool factoring with this thing. This isn't going to factor by grouping. So I'm just going to do synthetic again. I don't need this number anymore, right? Because now I'm down to just these. So you might plug in, you already knew that +1 didn't work. We tried it before, it's never going to work. So +1, I don't ever have to try again. You might want to try -1 again, just in case it's a double root. But I think the next one that works, just in the interest of time, happens to be a -2. So let's drop it down and get a -2, -2, 4, 2, -4, 0. Ding, ding, ding. So now there is my last remaining answer. Now, what are you supposed to do with these? This x² minus 2x plus 2. You don't have to do anything. If you were to solve that, it would give you these, the imaginary ones, but they already gave them to you. So I don't actually have to solve that. You can if you want, but why bother? I already know the two answers because they told me. Any other questions around 6? All righty. Oh, 7 is the graphs. So I'm going to flip to my full page here. So my graphs, remember, your graphs might look a little different than mine. The things that we are looking for. I will be checking that your ends are going the right way. So both ends need to be going the right way, either both down, both up, one down, whatever. I'm also going to be checking that your x-intercepts are in the right spots. And then I'll be checking that you bounce or pass through at the right spots. As far as the rest of the graph goes, I really don't care. So yeah. Which of these do you want me to talk about? Let me zoom out so you can see all of them. Again, yours might look a little bit different, but double check that you have the dots in the right spot and bouncing and passing on your end.
Wait. Can I do number 3?
Sure. So number 3, first thing I want to figure out, let's zoom in a bit. Since this is not written in standard form, I'm certainly not going to take the time to rewrite this in standard form. You could, but why bother? I have an x right there. That x is going to get squared, and that x is going to get squared. So don't I have, if I were to multiply all of that together, wouldn't that give me x to the 5th power? Because I have a squared, and 1 to the 1st. So even without multiplying the whole thing out, which would be a total nightmare, but you could, I can already tell it's going to be an x to the 5th. So this will be a 5th degree polynomial. I also know that the lead coefficient, although I don't know what it is, it's going to be positive, right? Look, if I just look at all my first terms, if I multiply them all together, it's going to be a positive number. So that tells me I'm going to have a 5th degree polynomial where a is positive. Does that make sense? Is everybody okay where that came from? You just have to look at all of your first terms. That first term will be getting squared. That first term will be getting squared. So I have 2, 4, and a single. So there's 5th degree. Everybody's positive for those first terms. So I know I'll have a 5th degree where a is positive. Now, because it's already factored, I can tell where my zeros are. When you have an x all by itself, what's the answer that comes from that? 0. So this thing will be touching the x-axis at 0. Then I have 2x minus 4. So if I were to solve that, I'd add 4 divided by 2. I get 2, right? 2 is a solution for this chunk. But since it's squared, aren't I getting that answer 2 times? So I'm getting 2 as an answer twice. So that's 2 is a double root. And then I do the same thing over here. I minus 6 divided by 3. So that's a negative 2. I'm getting that answer twice. So I'll have negative 2 as a double root as well. Now that I know where those zeros are, I'm putting dots there. So I'm going to put a dot at 0. I'm going to put a dot at positive 2. And I'm going to put a dot at negative 2. I wish I had a, I do. Like, I wish I had a blank one. I literally have one right next to me. Okay, so we have dots at 0, positive 2, and negative 2. Of course, the lines on this are like barely visible, but that's okay. Show me what, if it's in a 5th degree where a is positive, show me with your hands what the ends should be doing. Well, let's start with if it's an odd degree, are the ends both going, are they going to be together or are they going to be opposite of each other? They're opposite of each other. All the odd degrees, they're opposite of each other. right? So if you have, you can always go back to something easy. Like think of a super simple odd degree, like y equals x plus 2. Don't you know what that graph looks like? Of course you do. Looks like that, right? Look what its ends are doing. Isn't that easy? So there's an example where you have an odd degree, A is positive. Look at the ends. This one's going down, this one's going up. So that's the same thing this one will be doing. Isn't that nice? So nice. So now I know my ends are doing this and this. All right, cool. Now let's just figure out where we're bouncing and where we're passing. So remember what my answers were. At 0, am I going to bounce or pass? Pass. How do you know? Right, you only bounce at double roots. Or, I shouldn't say that. Any answer that appears an even number of times. So double roots, if I had something that appeared 4 times as a root, 6 times, that's where it's going to bounce. If it appears an odd number of times, it's going to pass. So my graph is going to pass through only at 0, and then it's going to bounce at both 2 and -2. So let's see what this looks like. If you're going to bounce at -2, that means I don't go through. I'm going to bounce off of it. I'm going to pass through at 0, and then I'm going to bounce again at +2. So you end up with a graph looking something like that. So if you look at yours, at -2, you should not be passing through the x-axis. It should just come, touch it, and come back. You should be passing through at 0, and then you should just be bouncing again at +2. Any other graphs anybody wants me to talk about from round 7? Again, there's the answers. Other graphs you have questions on? Anna? 2, you bet I can. So 2, let's just use our blank copy again. All right, so this one's already factored for us, but that also kind of means I have to take a minute and figure out what the degree would be. So if I were going to multiply all of these first terms together, that would get me an x to the what power? To the 4th. I have x squared right there, and then I'm going to get another x times x is going to give me an x squared when I multiply these together. So x squared times x squared, I'm going to have an x to the 4th. So this is a 4th degree polynomial. What is my lead coefficient going to be? Negative. I've got this negative out in front. So show me with your hands, if you have a 4th degree polynomial where a is negative, show me with those hands. Yes, they're both down towards the ground. Okay, so my end behaviors are both going to be like this. Now let's just figure out where those zeros are. So the x squared, what answer comes from that? 0 as a double root. From here, I'm going to get a -2, and then I'm going to get a +4. And now I'm ready. 0, -2, and a +4. 1, 2, 3, 4. You already told me the ends both go down. And at -2, am I going to pass or bounce? Pass. I'm going to pass through. Then I'm going to come over to 0. At 0, do I pass or do I bounce? Bounce. And then it lines up that at 4, I'm passing through as I should. Yes. All right. Anything else round 7? All right. Round 8. Oh, yes. Round 8. So remember our shortcut with these. Well, there's actually two things you gotta remember. So anytime you have an imaginary or an irrational root, they're only gonna give you one of them, like a number 5 here. They only give you these two, but you automatically know that 3 minus I and 1 plus root 5 are also roots. Automatically, they're only gonna give you one. So, I don't know, should we do 5 then? I'll take that as a yes. Okay, cool. So 5. So one root is going to be 3 plus I and 3 minus I. And then I have another one that's 1 minus root 5, and then it'll also be 1 plus root 5. So it's my job to come up with the polynomial that has these as their roots. It's easier than you think, especially if you remember our shortcut. Do you remember x squared minus the sum of the roots times x plus the product of the roots? This is our fast way to figure out, hey, what's the quadratic that has these two as their roots? Well, if I just find their sum and product and pop them into this, I have that answer already. So the sum of these two things is just 6, right? Because the i's cancel, so we get 6. The product, I have to spend a minute to FOIL that out, but that's no big deal. Especially because the i's are going to cancel out. Sorry, trying to get this lined up here. There we go. So let's find the product of this. First, 9 outside minus 3i plus 3i cancel.
Wait, so which one do you have to do? Do you have to go for both? And then
Yeah.
have the two equations?
I'm gonna do it for both, and then I'll multiply those two answers together. And then last here, I'm gonna get a minus I squared. What's I squared really? Every time you see I squared, what's it really? -1. So minus -1 turns into a +1. So the product is actually 10. So these two things come from this quadratic, x squared minus the sum, minus 6x plus the product. So there's the first one. Now I have to do it with the irrational roots too. Sorry, there we go. So I do the same thing. I have to find the sum. Sum of these two things is just 2. The product, I got to multiply it together. 1 minus root 5, 1 plus root 5. Let's see where we end up. 1, outsides, insides cancel. What is a negative root 5 times a positive root 5? -5. So that's a -4. So when I put it all together, I get x squared minus 2x minus 4. So now all you have to do is multiply these two things together. And that's how you get your final answer. Does anybody need me to do that, multiplying that out? Yeah, okay. Let me get another sheet because I'm out of room. Ah! And I ripped it. That's okay. Okay, so if I'm going to multiply these two things together, so that's a 3 by, this is a 3 by 3, so I should have 9 things before I combine my terms. So I'm just going to take x squared multiplied by all 3. So that would get me x to the 4th minus 2x to the 3rd minus 4x squared. Now I do -6 times all 3, -6x, sorry. So it'd be a -6x to the 3rd plus 12x squared plus 24x. Then I do +10 times all 3. So that's plus 10x squared minus 20x minus 40. So I should have 9 things in this crazy list. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do. So now all I have to do is combine my terms and I'll be done. X to the 4th. Let's see. Thirds. -8. Squareds. I have. That'll be a +8 plus 10. So that's a +18x squared. X to the first, I have 24 minus 20, so plus 4x, and then minus 40 on the end. And we cross our fingers and hope that that's the same thing as the answer that we have. It's not. We have a, what, maybe I just copied the key wrong because there's a 44x, not a 4x. Let me double check my x's. Minus 40, minus 20. No, I think I'm right. So I think on the key, I had a 44 right here. Should have just been a 4. Did everybody else do this out and you got a 4? So a 44? I think I just copied my key wrong. All righty. This is gonna bother me now. 1, 2, 3. So it would have been my second number plus 24. No, I'm right. Yeah, it's a plus 24. Okay. All right, so there is a round 8 in all of its glory. We got one round left. Any other questions on 8? Or we're okay? Last one, my friends. Number 9. Here they are. Do you remember sum and difference of cubes?
No.
That's okay. I'll help you remember.
Sorry.
So let's just do number 1 because that one's, if you're trying to solve this one, 2x cubed plus 54 equals 0. I hope that you said to yourself, oh, well, couldn't I divide both sides by 2? Can't you? Yeah, so let's do it. Divide both sides by 2. Just make your life easier. X cubed, that's a 27, I believe. There we go. And then I hope when you get here, I hope it's jumping out at you. Oh, that's the sum of 2 cubes. I remember that. We had 2 formulas. If you have the sum of 2 cubes, it looked like this. A plus b, and then a squared minus a times b plus b squared. That was the sum formula. And then there was a difference formula. So if you have the difference of 2 cubes, it's the same thing. The signs just change a little bit. There they are. Okay, so according to this particular problem, this is a sum. So I'm going to use the sum formula. So I just say to myself, oh, okay, well, what's the cube root of this thing? That's what I'm going to plug in for a. So what's the cube root of x cubed? X. And then this one, same thing. What's the cube root of 27? 3. So that's going to go in for b. So if I have the formula, it should be relatively easy because I'm just popping everything in. So this is now going to be x plus 3. A squared will be x squared. Multiply the 2 together. So that's 3x. But I minus 3x plus 9. What am I supposed to be doing here? Solving. So I have one of my answers. One of my answers is -3. Put it over here. So cool, I've got one answer. The other answer is going to come from this. So in this case, you can't factor this. This doesn't factor again. And I would not want to do completing the square, so I'd have to do quad formula on it. -b plus minus big O square root b squared minus 4 times a times c all over 2a. So just cross your fingers that you don't mess this up. That would be a 9 minus a 36, right? Is that 9 minus 36? So that gets me a negative 27. And then I just have to fix that. So I know I'll come over here and fix the square root of negative 27. So I know I'll pull out an I, and then I also have 9 goes in 3 times. So I'd have 3 root 3, and don't forget the I comes out. So I really have 3I root 3. And that is the square root of negative 27. So then I'd have 3I root 3, and the whole thing is over 2. There are my remaining 2 answers that I was looking for. So remember, there's going to be 3 altogether, and now I have them all. I don't think you will.
Yeah, me too.
No.
I don't think so. Well, which topic are you still like?
I just, because I didn't get through all the review, and I thought we were gonna like, do it in class today, but.
Well, yeah.
So I didn't really do it over the weekend, so I didn't really get through like. I literally didn't get past through 5.
But, so, remember though, if you look at, so 5, rounds 5 and 6 are the same thing. And then 7's just the graphing. Is that okay?
It's what?
The graphing?
Yeah,
And then, I mean, 9 is the same. 9 just has the cube roots, which,
yeah, I just don't remember the one.
there they are. Would it be helpful if I gave you the formulas tomorrow?
Yeah, so
These two?
sometimes that's stressful.
I'll give you them. Any other questions right now that yep. Oh, sure. Do you want another difference of cubes or sum of cubes or? Yeah, okay, so how about we take a look at what?
What about 4? Because that one's big.
4 you're supposed to skip.
What? Was this on like, okay, and do 2.
You can do 4. That I told you to skip. Oh, no, wait. No, yeah, 4 I did want you to skip. Which one do you want? 2?
Yeah.
All right, so if I'm gonna do 2, so let's see. I want to solve this thing. They don't give me any sort of jumping off points. There is one little thing, shortcut that you could do here, but I'm not going to get into it right now.
It's not on the screen.
Oh, my camera froze. Oh, no, it didn't. Just kidding around. There we go. All right. So I guess I would just find my list of possible rational roots. And luckily, 11 is prime, and my lead coefficient is just a 1. So that's it. If I'm going to have any rational roots, it's either positive, negative, 1, or 11. So let's just pop them in. 1. I need a 0 because I don't have it to the 3rd. 2nd, I don't have it to the 1st, and an 11. So let's pop in a 1, see what happens. What luck! We got a 0 on our first try. What does that mean? That means let's keep a list of all of our answers. 1 is one of the 4 answers. Yes. So now I'm down to this, right? Remember what this is. That's your remainder. There's your constant. X to the first, x squared, x to the 3rd. Oh, I think you can factor by grouping. Oh my gosh, oh my gosh, oh my gosh, oh my gosh. Let's do that. I have this 4-term polynomial, right? Let's split in half. From this side, I can take out an x squared. I'm left with x plus 1. From this side, I can take out a negative 11. I'm left with x plus 1. Yay! So one of my factors is x plus 1. The other one is x squared minus 11. I found another answer, negative 1. Yes, put it in my list so I don't forget about it. And now all I have is x squared minus 11. So just take x squared minus 11, set it equal to 0. Bingo, bango. We're almost done. Square root, square root. What do you have to remember when you take square root? Well, yes, plus and minus. Good answer. And there are my remaining 2. And I found all 4.
So the graphic ones, how do we do again, whether it goes down, it's like 2 different ways.
So if they are, if your degree for graphing, if your degree is even, they're going to go together. So let's say degree is even.
Is it the degree of all the added or just the meaning coefficient?
Just your, so let me grab my. So if I'm doing number 3, for example, or 6, your degree is just the 3.
Oh.
Right? So that one has an odd degree. If the degree is even, that's when they go up or down together. So degree is even, ends go together. And then it just depends. If it's positive, they're going to go up together. And if that's the Lie coefficient. If the Lie coefficient is negative, they go down together. So now if my degree is odd, they're going to go opposite ways.
Okay.
So they're going to do that if A is positive. And if A is negative, they're going to do the opposite. So they go that way and that way. What else you got?
Can you do like 5 or 6 on 9?
Sure. Okay, so let's take a look at 5. Your easy way, here's 5. So I have 3, 2, and I. So are there any other zeros that I actually have that just aren't here?
Negative I.
Yes, negative I is also a root, even though they didn't tell you. You need to know. So my answers are actually going to be 3, 2, I, and negative I. So now let's do that sum product thing to find my answers more quickly. So remember, it's x squared minus the sum plus the product. So, and you can do it with just numbers too. The sum and the product, it's just that much faster. So the sum of 3 and 2 is 5, and their product is 6. So the quadratic that comes from those two is x squared minus 5x plus 6. So there's that one. Then I do the same thing for this. Sum of these two is just 0. The product of these two, that's negative I squared. What's negative I squared really?
1.
Positive 1. So that turns into x squared, and then minus the sum, it's not even there because it's a 0, plus the product. And now I just have to multiply these two things together, and I will have my answer. So let's see. I'm gonna do it backwards. So I'll do x squared times these 3. And then 1 times all of these. Combine my terms and we'll be home free. Yes. Yeah, you sure can. Any other questions right now? All right, let me stop this video.
Are you gonna post it?
I sure am.
Yay.